Okay, so now we're going to talk about open area models. So I'm going to start talking about them based on a 7x6 rectangle. So when I think about what a 7x6 rectangle could look like, or an open area model for that, one way that we could see that is that they saw 7 by 6, and so altogether we have 42. So when we're thinking about an area model, we put the area, an open area model, we put the area on the inside, and then we have dimensions on the outside. That's what area looks like. But there are lots of different ways that could look. So maybe another way that could be drawn is maybe a student saw it as 6 by 5 and 2. So they would have 30 here and 12 here and still have the 42. So this is what the open area model would look like. If you want to somewhere say that, well, the 30 and the 12 go together and get 42, you could put that on the outside, maybe with a circle, something like that. Maybe another way, maybe someone could see this as 7 and 5 to get 35, and then another 7. And then 35 and 7 is 42. So this is what the open area model looks like. It doesn't just have to have two pieces. Maybe a student would see that as 7. Oh no. Maybe instead of that, maybe they would see it as 14s. So maybe they see 2 7s, 2 7s, and 2 7s. So 3 14s to get their 42. And so then it's a little bit different to think about what do their dimensions look like. So they would have the 7 out here, and then they've broken the 6 up into 2, 2, and 2. So when you're first starting out, maybe when it might just be you just want to include the area in the middle. So maybe you would just write this as 30 and 12 and not have the dimensions. I think that's okay to start with to help keep us fluid as the teacher. We can maybe start there, but we want to build up to where we are including the dimensions on the outside, because that's helping students see so much mathematics that's going on. They're seeing the decomposition of the number of a lot of numbers, and this so that's a huge thing that we're showing them, is that the flexibility to see 7 or 5 and 2 or 6 and 1, however they decide to break it down. But also, these are smaller versions of the area models that they are going to use for multiplication and division of larger numbers. So by including the dimensions on the outside, we're reinforcing that grade level content standard as well. Another thing that I've sometimes seen before is we kind of mix in, so maybe in here we would have something like 5 times 6 equals 30, and maybe here we would have 6 times 2 equals 12, in addition to everything else we've written. A true open area model would not have those things, and I think it can be a little bit distracting if we're trying to move them from the area model to maybe an abstract way of thinking. We could write those on the outside of the model, but I think there's real power in just letting the representation be the representation. So living in that semi-concrete world without having the equations in there, just letting them connect the representation to the actual image that they saw.